So today we're going to make some equations of lines for certain problems. There's 5 examples following. But before we get going, I want to make sure we understand positive slope, negative slope, vertical and horizontal lines. First of all, a positive slope line would look something like the green line here. And that would mean that the m in this equation is greater than 0. It is positive. Likewise, a decreasing line like the red line, okay, would also be the same equation because it is a diagonal line, but this slope m will be less than 0. That leaves our 2 special cases, which are a vertical line, which is always x equals a number, or a horizontal line, which is always y equals a number. We have those 2 special cases in the 5 problems. We'll talk more about them there. So often in geometry, it looks something like this. Write the slope-intercept form of the equation of the line through the given points. And the first thing I do is I look at the points through 3, 1 and negative 3, 0. And the first thing I'm going to do is just plot the points. All right, B and A. And the first thing I notice when I do the line is that it's not horizontal and it's not vertical. So then I know to bring out this equation, y equals mx plus b. Now, you have to know how to find slope. There is an equation, but I don't teach that. I always say, hey, we can think of it as rise over run, and we can always do the math. And our math in this case is from B to A. So from 3 to negative 3, that distance is 6. From 1 to 0 is 1. It's a positive line going uphill. So in this case, our slope is rise of 1, run of 6. Awesome. Now, we have y equals, and you always need 2 things for these equations. You need not only the slope, but you need a point. Well, we have 2 points. I'm going to pick this one, which is 0.31, which means that when x is 3, y has to be 1. So now if we think of our line, y equals mx plus b. It's 1/6 for m, x plus b. We've got to find the y-intercept. And we can look here, and it's close to the origin. It has to be a little above. So we know it's like slightly positive. Well, let's plug in and find it. We'll use our values. 1 is y, 1/6 times 3 plus b. Do the math. Again, the big story here is you got to do the math. And I get, using your calculator, 1/6 times 3 is 1/2. Subtract half on both sides. 1 minus a half is a positive half for the y-intercept b. The last thing we have to do now is use our y-intercept of 1/2, our slope of 1/6, and write the equation line. Y equals 1/6x plus a half. This is the equation of a diagonal line. This had a positive slope. It's going uphill. For number 2, it says through 1, negative 5 and 1, negative 1. When you plot those points, and I call them C and D, quickly I think you'll see that this line is straight up and down. So what you got to catch here is which value is not changing. The x value is not changing. So in our special case, it's just x equals 1. Notice I didn't write y equals mx plus b. This is not a diagonal line. We have to use our special cases. All right. I'm going to go to the next 2 problems on this worksheet. It's also linked in here. And then on all 3 of these last cases, we will go quite fast, so you want to take a chance to practice it. All right, for problem 3, it's find the equation of the line in slope-intercept form for the point 3, negative 3 and the point 2, 2. So the first thing I do is I plot it and decide if it's one of my 2 special cases. When I plot the points and make the line, we can see it's negatively sloped. It's going downhill. Therefore, it's not a special case x equal or y equals, so it's y equals mx plus b. And again, I'm going to move up the triangle between the points. And from the points, not on my grid, I can't count this, the distance between 3 and 2 is a run of 1. The distance between negative 3 and 2 is a rise of 5, or negative 5. And again, I do the math from the points. And if I get that, then the slope is -5/1, or simply -5. So I plug that in my equation for m. So y equals -5x plus b. I have to use a point. I prefer this point, 2, 2. They're the same. They're both positive. So x is 2 and y is 2. And we plug y in on the side over here. And then we just got some math to do here. So it's 2 equals -5 times 2 plus b, or 2 equals -10 plus b. Add 10 to both sides. I get a y-intercept of 12. When I look up on my graph, that kind of makes sense to me. Because if this is down here at, +2, it's just way up there. And again, not the scale, but it makes sense. So we simply write the equation, y equals -5x plus 12. All right, on to number 4. All right, problem 4. The point is 0, 0, the origin, and then the other point's -4, -5. So the first thing I want to do is make sure this is a diagonal line, that it's not a vertical line of x equals some number, or a horizontal line of y equals a number. When I plot the points, I see it's a positively sloped line going from the third quadrant up through the origin. And so that means the equation is y equals mx plus b. And again, I'm going to find the rise over run by forming a triangle between the points. And I'm going to do the math here. The distance between 0 and -4 is a horizontal run of 4. The distance between 0 and -5 is +5. We know this is a positively sloped line, so the slope is 5/4. This time, I know the y-intercept. When x is 0, y was also 0. This is the y-intercept. So I can write the equation right now, even though I have this form, y equals 5/4 x plus b. But from this point, I know b is 0. So the equation of this line is y equals 5/4 x. Everyone, if you want to use the point 0, 0, put in 0 for y, 0 for x in this equation right here. You'll get 0 equals 5/4 times 0, so 0 equals 0 plus b, so b is 0. Everyone, we don't write plus 0. 5/4 x plus 0 is 5/4 x. And again, we have just graphed a line in this picture here, and we have the equation of that line right here. Let's move on to problem number 5. All right, last problem on this worksheet. I have point -2, 3 and 0, 3. And again, as you practice more, you'll notice right away that this has an odd situation. You notice both y values are the same, and when you graph when the both y values are the same, you end up with this horizontal line. So we do not do this. That is only for diagonal lines. This is a special case. Well, you look at the points. What value didn't change? The 3 did not change. So our equation is y equals 3. Building on the intercept problem, we knew the y-intercept this time because when x was 0, y was 3. All right. Everyone, keep practicing. You'll get, it just takes a little bit of time.